Assalamu alaikum wa rahmatullah. Hi everyone. If you look at the files I shared for the coverage of grade 12 elite, I'm referring to the FRQs. The third question has many AP questions in this file. So, for the sake of time, I will be doing the first question only. And understanding this question is very important because all of the questions are having the same repeated ideas. So understanding how to do one question can help you do all of them. Again, for the sake of time, I will just focus on the first question, but I am willing to help you with any question in this file you need help with. So let's begin with the first question. Consider the differential equation dy over dx equals 1 plus y over x, where x should not be 0 in order for the differential equation to be defined, right? We cannot divide by 0. On the axis provided, sketch the slope field for the given differential equation at the 8 points indicated. Well, to sketch the slope field, we said we have to make a table, we have to create a table, whatever. So let's create a table of x, y, and dy over dx. There are 8 points, right? 1, 2, 3, 4. This is 5, 6, 7, and 8. Now, let's start from the x-axis, the bottom row. I mean the middle row. The middle row is starting from left to right, so it's negative 2 and 0, and then negative 1 and 0, and 1 and 0, 2 and 0, right? So what is the corresponding slope value for each point? Well, the first one, if we plug in negative 2 and 0, we will get negative half, so the slope is negative. Negative 1 and 0, that is equal to what? Negative 1, right? And 1 and 0, 1 and 0 is 1, and 2 and 0 would be half, right? 1 over 2. So let's discuss those 4 points. Negative half is this, right? So here, dy over dx equals negative half. Okay? Now, if you move to the second point, okay, it should not be parallel to the previous segment, okay? It should be having a different slope. The slope is negative 1. So this is how it should look like, okay? Where the slope is equal to negative 1. You don't need to write the value of the slope at each segment. I'm writing this just to help you understand the segments. Now the third one will be 1, which is just a normal segment with a slope of 1. And the last one in this row will be less steeper than the previous one because the slope is half. So this is how it would be. So here m equals 1 over 2. M is equal dy over dx. Let's keep it consistent. Dy over dx. Okay, so moving on to the 2 points on top. Let me change the color. The 2 points on top are negative 1 and 1, and 1 and 1. So if you use negative 1 and 1, negative 1 and 1, it will be negative 2. And if you use 1 and 1, that would be 2, right? So those 2 segments here, this is negative 2, and this is 2. So here, dy over dx equals 2, and here dy over dx equals minus 2. Well, moving to the last 2 segments, What are the coordinates? There is -1 and -1, and the last one will be 1 and -1. So both are going to be 0. So it's horizontal segments where dy over dx equals 0, dy over dx equals 0. Again, you don't need to write the values of the slope at each segment. Second part is find the particular solution y equals f of x to the differential equation with the initial condition f of -1. Notice that this is negative x value. Okay, we will use it later. I'll explain why I wrote this later at the end of the solution part B. And the state its domain. So the differential equation that we have is dy over dx equals 1 plus y over x. To find the particular solution, you need to use separation of variables by putting all the x's and dx's on one side, all the y's and dy's on the other side. So if you use the cross multiplication, you get x dy equals 1 plus y dx. Divide both sides by x and 1 plus y. Divide by x and 1 plus y. Now, if you cancel 1 plus y with 1 plus y, x with x, that leaves you with 1 over 1 plus y dy equals 1 over x dx. So I separated the variables. Please do not integrate before separating the variables, okay? Because if you integrate without separating the variables, you will lose a lot of points. Be careful. So now we can easily take the integral of both sides, right? So the integral of 1 over 1 plus y is ln of the absolute value of 1 plus y. And here it is ln of the absolute value of x plus c. Okay? What happens now? You need to get rid of ln by exponentiate the both sides, right? If you exponentiate both sides, here a and here a, what happens in this case? This is going to be what? Let me just write it here. E to the power of ln of 1 plus y equals e to the power of ln x times e to the power of c. Now, e to the power of c is constant, c is constant, so e to the power of c is constant. So this one, let's make it k. Okay, let's make it what? K. So now e cancels the ln, right? So what do we have now? We have absolute value of 1 plus y equals k. This one cancels this one, so we have k times the absolute value of x, right? Now we are given an initial condition. The initial condition is f of -1 equals 1, يعني the point is -1 and 1. Replace x with -1 and y with 1. What happens if you do that? You get 1 plus 1 equals k absolute value, انتبه, absolute value of -1. So absolute value of -1 is 1 times k. Absolute value of 2, so k equals what? K equals 2. So we have 1 plus y equals 2 times the absolute value of x, right? We can drop the absolute value from the left side, right? So we've got 1 plus y equals 2 absolute value of x. We can get the 1 to the other side, so y equals 2 absolute value of x minus 1, right? So if you look at the initial condition on top, okay, or this has a domain of the domain here will be all x except x is all real number except the one excluded originally in the question, which is 0. So x should not be 0 because on top here it's excluded, right? Now because the initial condition is negative, we must consider the negative domain, the negative x value. So this is for x is less than 0, right? For x is less than 0, this can be written as y equals minus 2x minus 1, again for x is less than 0. Okay, this is the answer of part B. This is the particular solution over here. That's it. Wish you all the best.